This video covers the material presented in Appendix A9 in the textbook. Appendix A9 deals with the normal distribution and the standard normal distribution. We'll talk in class about the difference between the two. We don't use the standard normal distribution very much. It adds a step. We have to convert our mean and standard deviation to a z-value, a z-score, to place it on the standard normal distribution. Characteristic of the standard normal distribution is that it has a mean of 0 and a standard deviation of 1. The text does give examples in this appendix using the standard normal distribution, so we'll go ahead and follow that. But in class, we'll get more into just jumping right to the normal distribution. So in the text, we're first given the example of the Hayes Construction Company. They're building apartment buildings, they have deadlines to meet, they have to complete this project within 125 days. They have some statistics regarding past performance. They know that they can complete projects like this in 100 days with a standard deviation of 20 days, and they know that this follows a normal distribution. So to solve this, we're going to go ahead and take their mean, which we're given, which is 100 days, and their standard deviation, which we're given, which is 20. And then they want to find the probability of finishing in less than or equal to, this is a continuous distribution, remember, so less than or equal to, they're the same. So less than 125 days. I'll put less than here so that we can keep in mind that we're finding less than. We'll go ahead and do the z calculation here, convert this x to a z-score, and we do that by using this equation, z equals x minus mu over the standard deviation. Here you see x minus mu over sigma equals 25 over 20. So then z equals, we'll go ahead and put that in, the quantity x minus mu, that quantity over the standard deviation. That gives us 1.25. So the probability of x being less than 125, we find that in Excel by using the norm.s.dist function. The norm.s.dist function wants to know the z-score, which we've calculated, and we're using a continuous distribution, so we're going to always answer true to the cumulative question. Always going to be cumulative, because this is going to find, here's the z of 1.25, so here's 1.25, and you can see that we're getting the values to the left, cumulative, all the area under the curve to the left of a standard deviation of 1.25, 0.894 or 89.5% of the area in a normal distribution is under the curve to a standard deviation of 1.25. That's what this function tells us. Norm.s.dist always returns the cumulative area under the curve in the normal distribution to the stated z-value, or the number of standard deviations, which is in this case 1.25. So we see that 89.4% of the area lies below sigma, or standard deviation, of 1.25. So there is an 89.4% chance that x is below 125 days. So they have an 89.4% chance of completing the project below the deadline of 125 days. Now, if we wanted to know the probability of completing it above 125 days, we would simply, let's change this to greater than 125 days. You can see now we want the area to the right. We know that the normal distribution consists of values between 0 and 1. We know that norm.s.dist always returns the area under the curve to the left of the standard deviation that we're given, the z value. We want, in this case, greater than the area to the right. In order to get the area to the right, we need to take 1 minus norm.s.dist, and again, the z value. And the cumulative is true in all cases with a continuous distribution. That tells us that 0.1056 or 10.6% of the area lies above a standard deviation of 1.25. You can see that area under the normal curve lying now to the right of 1.25 standard deviations. That's how we solve for area below a standard deviation and an area above a standard deviation, so less than or greater than, using norm.s.dist. The next instance that we're given in the text asks for us to find the area under the curve between two values. They go on to say, all right, what is the probability then that Hayes will finish the project between 110 days and 125 days? So we still have our mean of 100 days, our standard deviation of 20 days. Now we have an X upper, so we have 125 days. That's the upper bound. Then we have an X lower, a lower bound of 110 days. So we want to find the probability that X is greater than 110 and that X is less than 125. So we need to find the Z upper, converting X upper to Z upper, and Z lower, converting X lower to Z lower to get our Z score. So we'll go ahead and we'll take our formula for the Z score. We have it right there, which is X upper in this case minus mu, that quantity over our standard deviation. Then we're going to take our X lower, that quantity, minus mu, put that quantity over sigma. There we go. Now we have our upper and lower standard deviations. We'll convert these. We'll find the area under the normal distribution for each of these. We'll find the area to the left of 1.25 standard deviations. So we'll do norm.s.dist, and that wants the Z value. There we have it. And cumulative is true. Then we'll find the area to the left of a Z value of 0.5 using norm.s.dist, which wants our Z value, and cumulative is true. And then if we subtract the two, the upper minus the lower, we get the area under the curve between the Z value of 0.5 and a Z value of 1.25. We know that norm.s.dist will return the area under the curve to 1.25 standard deviation. So we calculate that first, gets us all the way out to here. Then we calculate the area under 0.5, which is an X of 110. That's the area to here. Then by subtracting this from this, the difference The value that remains is the area under the curve between the two standard deviations. So 20.3% of the area is between 0.5 and 1.25. So there is a 20.3% chance that X is between 110 days and 125 days. That's how you find probabilities using the standard normal distribution in Excel.